we said. Dominic, where'd you put my pen? I found it. You're gonna have to find a better spot than my desk to hide my pens, Dominic. Just letting you know. Okay, 28th today. Equivalent fractions. It's a big word. Oops. So write our first problem down. Just to review, Ella, could you tell us why we can't add them the way they are right now?
Because they don't have the same denominator.
Yep. Common denominators. We need common denominators. Try to remember that term, folks, because we refer to those terms a lot. Common. Common, like, uncommon, and unlike. So we need to change them. Now we're not going to use money. We're not going to use the clock. We are going to do it the old-fashioned way. Think of an equivalent fraction. So there's multiple ways to do it, but when you're starting this out, most of the fractions are pretty friendly. We need to make a denominator, so let's draw our problem out over here, that both of these digits will fit into equally. So if you remember for our process of, not factors, but, oh my goodness, blanking. Yes? Not the factors, but what? I'm forgetting my word. Products. Or not products. No. No. Oh my goodness. No. Multiples, thanks. Count. This is one way to do it, because sometimes, now these are two friendly ones, but if you can't think, or if you don't notice that these are friendly, and I'll go over that in a second, count by one number and count by the other one until you hear the same number. So if we counted by fours, what would we get? Count by fours and write these down, everybody. Count by fours. 5 times.
20.
And 20. I recommend you do it at least 5 times. So all of you should have that written down now. Those are all the multiples of 4. Well, not all of them, but 5 of them. Then list the first 5 multiples of 8. Go ahead.
8, 16, 24, 32,
And 40. The more you do that, the faster you will get. Now, look at both lists. Is there a multiple that you see in the top list and the bottom list? Cole?
8 and 16.
8 is one. 16 is another. Any others? No. Now, of those two numbers, which one is the least or the smallest? 8. So 8 is our least common multiple. It's the smallest multiple of both of these. So that would be our least common denominator. So here it's a multiple, but once we put it below that line, it's now our least common denominator. You could have used 16. What other numbers could you have used? What would be the next multiple? Clara? 24. But then you're going to have to reduce a whole bunch. Now if you look at these, like I said, 4 and 8, those are friendly numbers. If you look at those two, most of you already knew what was the least common denominator. 8. So when you see fractions, first, look to see if the smaller one fits into the bigger one equally. If it does, then use that as your least common multiple. If that doesn't work, you can also do what with these two numbers? Multiply them. So we could have used 32 also. But then you're going to have to do what for sure? Reduce. Or we do this method. Or money. Or clock. 5 different strategies you can use. You can pick one, or you can do all 5. So let's convert these. Now this is the trickier part that some of you have trouble with. So we have to convert 2/4 to eighths. 2/4 is the same as how many eighths? Anybody know? Trev?
40.
Let's check. How do we get 8? If we are at 4, what do we multiply times 4 to get 8?
Can I put my chair over there?
Yep. 2, right? So 4 times 2 is 8, so then we do that on the top also to get 4/8. 8 times 1 is 8, so 1 times 1 is 1. And now, according to what Ella said, we can add them because both of our denominators are what? Yep.
The same.
Common, yes, they are the same. So 4/8 and 5/8 simply equals what?
You said the answer. You said 4/8 and 5/8.
Oh, well, that'd be a different problem. So what does it equal? 5/8, very good. Yeah, I do that a lot. All right, here's the next one. 2/3. Now first, like I just said, look at them. Does anybody see what the common denominator could be? Elian? 6. Because the 3 fits into the bigger number, we can use 6 for our LCD. So let's do that. So here's our least common denominator, the LCD. Now we have to convert. 2/3 equals how many sixths? So ask yourself, 3 times what gives you 6? 2. And if we do it on the bottom, we do it on the top. 2 times 2 is? 4. And then this one just becomes what? 1/6. Now we can add them together because, why? The common denominators. So 4/6 and 1/6 equals 5/6 again. So that was a pretty easy one. Now if you think about it for just a minute, earlier we said if you skip count by 2s and 3s, you'll get what? What did I teach you a minute ago? If you count by the numerator and count by the denominator, what will you get? What? But what kind of different fraction? An equivalent fraction, yes. So if you count by 2s, what do you get? Count by 2s. 2, 4. Count by 3s, you get what? 6. So there's a sixth way. You can just count. Skip count by the numerator and denominator and see if that works. Okay, let's try this one. Let's do this one the old school way. 2/6 and 3/4. Then we'll get going. We need practice at listing multiples because that'll come into play later. So let's list some. So down here, put a 6 with a colon. List the first 5 multiples of 6. Who can list the first 5 multiples of 6? Count by 6s 5 times. You're not racing, so take your time. Mr. T, go ahead.
6, 12, 18, 20, 22.
Yep, 6 times 1 times 2 times 3. And 6 times 4, 24. One more. There you go. And I should have put 6 in here. Now the multiples of 4. Who can count by 4s 5 times for us? Elian?
4, 8, 12, 16, 24.
There they are. Once you do this a bunch, this will just stick in your brain. Now look at your 2 lists. Are there any common multiples there? Zach?
12.
Just 12?
Yeah.
Here's a 12, there's a 12. Any other common multiples? Bensky? 24. So there's 2 common ones. We could use either one. Which one are we going to use? 12, because it's our least common multiple. And once you put it under that line, now it's your least common denominator. And now we convert. So let's look at this. Here we got a 6 and a 12. Count by 6s once. What do you get? 12. So that means if we count by 2s once, we'll get what? 4. Try it over here. Count by 4s till you get to 12. What do we get? Go.
4, 8, 12.
How many times did you count?
3,
So we count by 3s. How many times?
3, 6, 9.
3 times. We get 9 twelfths. That's the easiest method of all. Now if we add 4 twelfths and 9 twelfths, how many twelfths do we have? Slinky? Nope, 9 plus 4. Because now we have 2 pizzas that are cut into 12ths. So Cole brings over his 4/12 of his mushroom pizza. Clara brings over her 9/12 of her sardine pizza. How many slices do we have? Sam, how many we got? 13/12. What kind of fraction is this? Improper, so let's change it. Right now, we still just have 13 slices. Let's make them into as many whole pizzas as we can. How many 12s fit into 13, Sam? If you're saying anything, I can't hear you. 1, and then we have 1/12 left. Good. So by far, I would say just, if you count, and all of you can count, just count by the numerator and the denominator, and you'll get that equivalent fraction. And this will get easier as long as you're here and you're engaged.